Hi guys and Assalamu alaikum. Welcome to my new blog post 25. And in this blog post, I'm going to discuss about algebra of sets. So it will be a brief overview about the algebra, which is related to the sets. So without further ado, let's start. So we actually know that the algebra of numbers include many operators like addition, subtraction, multiplication, and division, etc. So likewise, algebra of sets basically includes its own collection of useful operators like the operation like operators of arithmetic. So some of these set operators basically combine two sets and actually yield in a set as well. So uh, we can actually say this like algebra of sets basically defines the properties and laws of sets. The set theoretic operations of union, intersection, and complementation, and relations of set equality and set of inclusion. It also provides systematic procedures for evaluating these expressions and performing various calculations involving these operations and relations which are required to be performed. Uh, so when I talk about like what kind of algebra of sets, algebra that I'm going to utilize on sets. So first one is basically union. So when I talk about union, I assume that there are two sets, and uh, these sets basically belongs to the same universe. Uh, let's suppose U. So the union of A and B actually uh, will will merge into another set, and that will be our resultant set. So it's a theoretical description about the union set. So in future, I'm going to give you a more brief overview about uh, union. Next comes is basically intersection. Intersection means like if you have two sets, but the common members between these two sets actually combine into a one set, and both sets actually do belong to our same universe. So, and next one is the difference. Difference means like you have two sets, but uh, you need to exclude members of one set from another set. So this is just like a subtraction or right or division. Another one is the power. Power means like you need to power set means like if you have a set A and whose members are actually all possible subsets of that set A. For example, if you have a set which has only one member, two members, so it means like it will have 2 raised to power 2 number of sets in it, right? So this is the power set. Another one is Cartesian product of the sets. Like when you multiply two sets with each other, you will actually get the Cartesian product. So this is further going towards the algebra of sets. It means like complement. Complements mean like if a set member, if a set has something which is actually present in it, but you want to have another set which is actually which should have like all the members except the members of A, you will actually utilize the complement. Like for example, if you say like I have a binary set and it has a or it has only one member like one. So the complement of one is normally equals to zero. So it's like that, like something which is actually alternative to that certain set. So we talk about this more in our later slides. Uh, Another one is the equality. Equality means like you have two sets, but those sets must be equal to each other. And then there is a eighth one like inclusion. It means like A is a set and it's a huge set, and then there is a B set, and A actually includes the B itself. Yeah, this is the basically a concept of subset. So one set actually include more sets as well. So by the definition of the set, this is actually true. And you can actually review my last video as well, in which I actually talk about this thing. So I hope so. You have understood the concept of algebra of sets. So please do not forget to subscribe, like, and share my YouTube channel, YasirFazal. Please do not forget to hit the bell icon so that you should get the latest video as soon as it is actually uploaded. And as always,